I'm Anil Kumar. Welcome to my YouTube channel. In this video, we'll discuss the relation between exponential and logarithmic functions. The foundation will be laid with 6 questions, which is your worksheet. In case you want to learn from me, you can join my classes by sending an email on the address given. Enjoy the journey of success. Now, let us explore the worksheet. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss a worksheet on logarithms. Worksheet 1. We'll look into the basic concepts of logarithms with the help of 6 examples. Well, let's talk about logarithms first. Most of you know, inverse of exponential function is logarithms. Let us connect these points before we get into the questions. Y equals to x squared. How is x related with y? Well, x is equal to square root of y, correct? Y equals to 2 to the power of x. How is x related with y? That is where the logarithms come into picture. Logarithm as inverse of exponential function, that is what we are going to look into. Inverse of y equals to a to the power of x is x equals to a to the power of y. How to solve for y? We'll have examples on this. Y equals to a to the power of x implies that log to the base a of y is x. And this is also a very important relation. A to the power of log to the base a of x is equal to x. In short, 32 equals to 2 to the power of 5. This is the exponential form. You can say that logarithm to the base of 2 of 32 is 5. So that is the kind of relation which we are talking about. So the exponential form 32 equals to 2 to the power of 5 is equivalent to logarithm to the base 2. So the base of 2 remains the same. Of the number 32 is 5. So that is how we evaluate x, right? So this is what we are going to look into. So 32 equals to 2 to the power of 5 is same as log to the base 2 of 32 equals to 5, right? So I hope this is absolutely clear. Now let me share with you the 6 questions. Question number 1 for you is, find logarithm to the base 3 of each of the following numbers. Question number 2. Evaluate the following expression and show that a to the power of log to the base a of x is x. Question 3. Complete the following table with equivalent exponential and logarithmic statements. So in this question, 2 to the power of 10 is 1024. You have to write equivalent logarithmic form. Question number 4. Complete the following table with equivalent exponential form. We are given the logarithmic functions this time, and you have to write the exponential forms. Question number 5. Write the equation of each inverse function in different forms. So you have to write equation of inverse function in exponential form and in logarithmic forms. Question number 6 is, sketch the graph of each inverse function, not y equals to 3 to the power of x, it's inverse. So sketch the graph of inverse of y equals to 3 to the power of x and y equals to half to the power of x. So these are the 6 questions in the worksheet. 1 for you. I'd like you to pause the video, answer these questions, and then look into my suggestions. So before we answer the first question, let's look into the characteristics of the logarithmic functions. So it's kind of a short review. Let's look into the exponential function y equals to a to the power of x. Now, if a is greater than 1, then what we have is shown here, correct? Exponential graph, which increases. And for the same graph, the inverse is a logarithmic graph, which is also increasing, reflected on the line y equals to x is shown in the graph. However, if a is greater than 0 but less than 1, in that case the exponential function is decreasing as shown here, and logarithmic function, the inverse of exponential function, is also decreasing. Note the graph carefully. That may be required in one of the questions. Now, if y equals to a to the power of x, we know that a should be greater than 0 and a is not equal to 1. X belongs to real numbers and y is greater than 0. On the other hand, if I have the exponential form, which is y equals to log of ax, inverse of exponential form, the logarithmic form, then that is the case, right? So in that case, what really happens is the conditions will remain the same. So the base a has to be greater than 0 and a is not equal to 1. But here, the domain and range swap, correct? Domain and range will swap, since this is the inverse of the function. So as you can see that x is going to be greater than 0, however, y belongs to real numbers, correct? Since that is an inverse function. So it is kind of important to understand this concept, and now let's begin with answering our questions. So now let us look into question number 1, which is find logarithm to the base 3 of each of the following numbers. So that really means that we need to calculate what is log to the base 3 of 9 in this case. So this is the number which we want to calculate. How do we get this number? Well, the strategy is very simple. We have to really figure out 3 to the power of x should be equal to 9. That is what we have to figure out. What power of 3 is x? You get the idea. Since we know that 3 square is equal to 9, x should be equal to 2. Do you understand? How do we solve this question, right? Let's look into part B, which is find the logarithm to the base 3 of the following number. The number is 1. So we need to find what is log to the base 3 of 1. So this is what we need to figure out. In a way, we are trying to solve the equation 3 to the power of x is equal to 1. What is x? Well, of course, anything to the power of 0 should be 1, and therefore our answer is that x should be equal to 2. You get the idea. That is how you could solve such a question. So finding logarithm to the base 3 of each number is same as 3 to the power of what is that number. You get the idea. So for example, you could do it like this. Square root 3 can be written as 3 to the power of half. That is square root 3. That really means that I could also write down that log to the base 3 of square root 3 is half. You get the idea. You could solve this question either way. It depends what is easier for you to understand. You get the idea. 1 over 27. You could write this first in the exponential form. 1 over 27, we are looking at the base 3. Since it is in the denominator, minus 3 is the exponent. And therefore, we could also say that log to the base 3 of 1 over 27 is indeed equal to minus 3. You get the idea. So that is from the definition of logarithms. Exponentials and logarithms are inverse of one another, and that is how they are related. I hope this is absolutely clear. Now let's move on and see question number 2. We'll basically illustrate that a to the power of log to the base a of x is indeed x. How do we find this? Well, 2 examples are there for you. You can pause the video and answer them. Now let's look into it. What is log to the base 2 of 8? Well, to find this, we basically are trying to figure out that 8 should be equal to 2 to the power of x. And we know 8 is 2 to the power of 3. So that means that log to the base 2 of 8 is indeed equal to 3. And now, see, we can write down the given equation, which is 2 to the power of log to the base 2 of 8 is actually equal to 2 to the power of 3, and that is equal to 8. Do you see that? So we have shown that this value matches, and that is what is the rule. Perfect. So a to the power of log to the base a of x is indeed x, which you can verify as shown here. I'd like you to attempt the next question, right? You could also write it like this. We are working with 3 to the power of log to the base 3 of 81, right? Now this is equal to what? Log 3 of 81 is what? 3 to the power of 4, right? So I could write this as 3 log of 3 to the power of 4. You get the idea? So log of 3 to the power of 4, and since this base is same, it should be equal to 4. So this is equal to 3 to the power of 4, and which is indeed equal to 81. That could be alternate way of solving this particular question. So I'm trying to show you different ways. Just as in question number 1, we could begin with logarithms and get to exponents, or we could begin with exponents and get to logarithms. And in question number 2, we could do them separately or together. You get the idea, right? Now let's look into question number 3. So we'll now complete the following table with equivalent exponential logarithmic statements. We'll see how exponential and logarithmic functions are connected. So if I have the statement 2 to the power of 10 is 1024, which you know is true, how do we write this as a logarithm? Well, the base is 2, right? So important thing is base remains same. That is kind of important, right? So in this case, base is 2. So we're talking about log to the base of 2. You get the idea. And log to the base 2 of 1024 is equal to 10. That becomes the logarithmic form, right? So it like flips x and y positions. You see that? So the x position and y position gets flipped. So now we get that as the y value. You get the idea? Similarly, here we have 3 to the power of minus 2 is equal to 1 over 9. So the base is 3 here, right? So log to the base 3 of 1 over 9 is equal to minus 2. Perfect. So I'd like you to complete the other two in a similar fashion, right? Not difficult. So basically, the base remains same, right? Log to the base 10 of 1 is 0, correct? Now remember one thing, that log to the base 10 can also be written as log of x. 10 is the default value. The last one here is 4 to the power of 5 by 2 is 32. Base is 4 and therefore we'll write this as log to the base 4 of 32 is 5 by 2. Perfect. So that is the way of writing in logarithmic forms. Here is example 4. We'll do the reverse. So in this worksheet, you get to know how to work with logarithms and exponential functions together. So this time we have given you the logarithmic forms. You need to write the exponential forms. Easy way is base is 3, right? So 3 to the power of 5. So you could write this as 243 equals to 3 to the power of 5. Do you see that? The exponential form. So you can take the base to the other side, leaving what is written there off, right? Do you see that part? So that could be the exponential form. So 1 is equals to half to the power of 0. You see that? So square root 3 is equal to 3 to the power of half. So that is so simple. So I hope you have understood this strategy. Perfect. Now question number 5 is write the equation of each inverse in different forms. Well, this is slightly different. We are not writing the function as such. We have to write the inverse function. Is it okay? So inverse function we have to write. So in exponential form, how do you write inverse of y equals to 3 to the power of x? Well, swap x and y. So we get x equals to 3 to the power of y. That is how you write this in inverse in exponential form. So just swap and you get your result. Do you see how simple it is? So I hope with that, there should not be any problem, right? So again, x is equals to square root of 2 to the power of y. So that becomes the inverse of these functions. Now when you're to write in logarithmic form, in that case, inverse will be what? So the inverse form for y equals to 3 to the power of x will be log to the base 3 of x is equal to y, correct? So you could write the statement in the logarithmic form. So we have log to the base 1 over 3 of x is equal to y. And in this case, we can write this as log to the base square root of 2 x is equal to y. You get the idea. So that is how we could write the inverse form of these functions. Now, let us look at question number 6, in which case we are going to sketch the graph of inverse function. So question number 6 here is sketch graph of each inverse exponential function y equals to 3 to the power of x and y equals to half to the power of x. You can pause the video, answer this question, and then look into my suggestions. We need to sketch the inverse of this function, not this function, right? So how will this graph look like? And how can you sketch this inverse of the function? Well, one way you could do is make a table of values. And then you can sketch it, right? So inverse will be what? Let's take 3 to the power of x as our function. So the inverse will be swap the points. Get the idea, right? So inverse of this function will be y equals to log to the base 3 of x, right? So we want log to the base 3 of x. That is what you have to sketch the graph for. You get the idea. Perfect. So if I take some critical points, then good points to consider will be 0 to the power. 3 to the power of 0 is always 1, right? And 1, if x is 1, you're getting 3. And if x is minus 1, you get 1 over 3. Now in the log function, which is inverse, the points will swap. So we have 1 over 3 minus 1, 1, 0, and 3, 1. So as you can see very clearly that the y-intercept, which was 1 for the exponential function, has now become the x-intercept, right? You also appreciate that when x approaches minus infinity, in that case, y approaches 0. Now here, when x approaches, because this is going to change, when x approaches 0, y approaches negative infinity. You get the idea. Y approaches negative infinity. That helps you to sketch this particular function, right? So now you can sketch the function, which will look like kind of like this. Plot the points and sketch the function. You get the idea. Perfect. So that is how your graph is going to look like. Now I would like you to work on the other formula and sketch this particular function also, which is half to the power of x. That is a test question for you. I'd like you to pause the video and do this particular question. You could also use the concept of reflecting on y equals to x. You can sketch a line y equals to x. I'm doing it for 3 to the power of x. 3 to the power of x is a function which will be kind of like this, right? That is 3 to the power of x. And then you could reflect it as shown here to get the function which is log to the base 3 of x. Perfect. The inverse of this particular function. Is that clear to you? So that is how you're going to sketch it. Now, just for the convenience and for you to check the solution, I have actually sketched the graph of half to the power of x right there for you, right? So your graph should look like something like this. Substitute the values, calculate, and then find the graph. So I hope with this you understand the concepts of logarithms. We actually verified that how do we relate exponential and logarithmic functions and also this important formula with the help of our questions. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.